Inside modern hardware, an RTOS acts as the invisible conductor. It manages tasks down to the microsecond and snaps everything into rhythm. If you build a simple, single sensor device, you can usually write a traditional bare metal superloop. The processor just runs through your code from top to bottom over and over, and that works fine for basic operations. Add a single new feature, like a user interface, and that simple loop breaks down. If drawing the screen takes an extra millisecond, the loop stalls. You miss a critical sensor reading, and your system timing shatters. To fix this problem, you need determinism. In embedded systems, raw speed takes a back seat to predictability. Guaranteeing a task finishes on a strict, predictable deadline is the core function of an RTOS. Moving away from bare metal requires a complete overhaul of how your device manages hardware resources and structures its code. Once you hit the threshold where you need an RTOS, you face a new problem. Picking the wrong operating system will sink your entire project. A poor choice creates performance bottlenecks. You end up with timing jitter and mismatched middleware refusing to communicate. It becomes a massive integration drain. Then there is the legal liability. Open source licenses carry strict, often overlooked rules about how you handle intellectual property. If you link your code to an RTOS with the wrong licensing terms, you may be legally forced to open source your proprietary code, giving away your company's core intellectual property for free. This scorecard highlights the true cost of a bad decision. Between performance bottlenecks, integration nightmares, and legal liability, selecting an RTOS is a critical business calculation that dictates whether your project survives. This comparison matrix breaks down our first bucket of reality: hardware constraints. Tiny microcontrollers have strict limits on RAM and flash memory, and your OS has to fit inside them. To save precious RAM space, developers often set ultra-conservative stack sizes when configuring their RTOS. If those stacks are not rigorously profiled, the system will eventually run out of memory during a complex operation. This results in an invisible, catastrophic stack overflow crash occurring out in the field. To prevent software bloat, Zephyr uses a highly modular kconfig build system. It allows you to compile only the exact pieces of the operating system you actually need. However, that modularity introduces a steep learning curve. Configuring kconfig requires much more initial effort than simply dropping in precompiled libraries. In highly constrained hardware environments, saving memory upfront frequently costs you substantial engineering hours on the back end. Returning to our matrix, the second bucket is ecosystem and middleware. This covers what happens when your core OS needs to talk to the outside world, requiring a network stack or a file system. FreeRTOS offers ultimate flexibility. You can stay completely cloud neutral and architecture agnostic, moving between different hardware with relative ease. The catch is that batteries are not included. Your engineering team must manually source, integrate, and test third-party TCP/IP stacks and file systems on their own. ThreatX, now Azure RTOS, takes the opposite approach. It provides a tightly integrated, cohesive suite of middleware like NetX and FileX right out of the box. You gain powerful visual debugging tools like TraceX, but you accept Microsoft ecosystem lock-in. The software is only free if you deploy it on pre-licensed silicon. Your middleware choice forces a direct trade-off. You either take absolute architectural freedom and accept the high labor costs of integration, or you choose seamless integration and accept strict vendor lock-in. Look at the final row on our matrix: safety certification. If you are building for medical devices under IEC 62304 or automotive under ISO 26262, the stakes are entirely different. Standard open-source RTOS options have zero upfront software licensing fees, but they carry a massive hidden cost for safety-critical applications. Your development team must absorb the multi-year financial burden of proving strict compliance to regulators entirely on their own. Enterprise alternatives like QNX, VxWorks, or Safe RTOS exist specifically for these environments. They provide pre-certified safety compliance and legal IP indemnity out of the box. This shifts the legal and regulatory liability away from your team and onto the vendor. You pay a severe premium for this assurance. These options require massive upfront licensing fees and generally demand a heavier system memory footprint. In heavily regulated industries, paying those large upfront fees for a commercial RTOS is almost always cheaper than paying auditors and lawyers down the road. Let's move from theoretical trade-offs to your specific constraints. This flowchart maps the path. Node 1 asks, Is human safety dependent on this device? If building an automotive dashboard or medical device, follow the yes path to QNX, VxWorks, or Safe RTOS to guarantee determinism. If safety isn't critical, follow the no path to Node 2. Are you heavily constrained by RAM and flash memory? The yes routes you to FreeRTOS or Zephyr. These offer maximum architectural flexibility at zero licensing cost. The required trade-off here is labor. Your engineering team has to be prepared to handle all of their own middleware integration from scratch. If building a complex connected edge device, you hit Node 3. Do you need pre-integrated middleware and visual debugging? A yes routes you to ThreadX. You gain seamless cloud integration and fast development, provided you accept the silicon licensing lock-in. There is no universally superior RTOS. There is only the logical mathematical match for your specific hardware, software, and business constraints. The primary failure point of most embedded systems is rarely the hardware itself. Devices fail because of a mismatch between the software foundation and the project's business reality. Do not select an operating system based purely on elegant code architecture, flashy new features, or a highly active online community. Your engineering tools exist to serve your team's existing bandwidth and toolchain familiarity. Map your constraints accurately. Select the RTOS whose specific compromises align perfectly with your company's business model.